All right, so it's a positive 2, so I'm going to subtract 2. I think you're probably okay up to that point. Agree? Okay? So now, what should we do with 3/5? There's all kinds of things. So go ahead.
You can times both sides by 5.
Okay, so we could times both sides by 5. What do you have? Do you have something different? The reciprocal. Okay, so remember this is one that I would have shown you the other day where there was 3 different ways to do it. I could multiply both sides by 5, then divide by 3. I could divide both sides by 3, then multiply by 5. Or I could multiply by the reciprocal, and a reciprocal means I flip the fraction over. Okay? So these all cancel out, which makes it nice. But sometimes there becomes questions about what do we do with this? So let's think about this as 6 over 1 times 5 over 3. So if you multiply fractions together, you can reduce it first off if you wanted to, or you could go, let's multiply top to top, bottom to bottom, so that gets me 30 over 3. And 30 over 3 reduces to 10. Does that help you out?
Yeah. Wow.
Okay. What else? Was there more of those you want me to do, or feel comfortable with that?
So would you just do the inverse op? So on 12,
12.
it was 5 over 7 x minus 3. Would you just...
So you add the 3 first, right? Yeah, you add the 3 first, and then you multiply both sides by 7 over 5. And that's the reciprocal. That's the flip over of the fraction. Okay? Yeah.
Could you do 10?
Yeah. 10, we got 2 plus 3 over 2 x, that's a 2, x equals negative 7. So again, we're going to have our equal sign on both sides. So let's go subtract 2, subtract 2. Does everyone feel comfortable with that motion so far? So that gives me negative 9. Okay. What's the reciprocal of 3 over 2? 2 over 3. So I'm going to multiply this by 2 over 3, 2 over 3 over here. Nice thing is, top to bottoms all cancel out, so I get x is equal to, well, let's take care of this part. So that's negative 9 over 1 times 2 over 3. So last time we just said let's multiply top to top to get negative 18, bottom to bottom to get 3. It's going to be a negative answer. What is 8 over 3? Yeah. Negative 6. Good. Done.
Oh, that got me wrong, right?
Yeah.
Why wouldn't it be negative 1?
Negative 1. Where are you looking?
9.
Oh, right here?
Mhm.
That's a great, so I can write that like this, or I can write it sometimes like in a book, it's written like that, or I could even write it like this. So notice I can have the negative at the top, in the middle, or at the bottom. It doesn't really matter.
It's like a staircase.
Yep.
So you can't have negative.
No,
Right, if negative over negative is positive. I mean, they could be listed to you as negative over negative, then you realize, oh, I'm dealing with a positive coefficient or a fraction. Anything else? Phone? Oh, I got a spot for that. Right? No, I got a spot up there. Remember, I got 3 simple rules. Same rule applies to me. What else would you like to see? Bless you. We good? Going once? Going twice? Thank you. All right. So let's get notes out from last time. If you don't have the book yet, just get it on a sheet of paper. And let's figure out what we're going to play with on this next adventure. And again, friends, I am available for if you want to come in and do homework with me, if you want to get questions answered, come in period 2, 4, 6, or 8. Next door. If those don't work for you, which that's possible, let me know during this period if you're going to come in, or sometime during the day if you can come in after school. I am not available before school because I have a morning class that happens before school on Monday, Wednesday, Friday, and on Tuesday and Thursday I have meetings. So excuse me. Periods 2, 4, 6 you can come in. 2, 4, 6, 8, or you can come in after school. But you please have to let me know if you're going to come in after school. And again, if you came in and you got your homework done with me, guess what homework you don't have to do at home? The math work, right? So, budget your time. Budget your time. See how you want to go about it. All right, so let's see. Let's see, what's on your first page? Is it the stop sign? So that was your first page right there? Is that it? Okay, so friends, this appears to be kind of similar to what we've seen, but it's a smidge different. What's different about this problem? Yeah.
Well, there's 4 plus 6 divided by 3 times is also an x.
Yeah, so notice I have like terms on the left side and I have like terms on the right side. Does that make sense when I state that?
Yeah.
Okay, so what we want to do is we want to combine like terms. So let's take care of what I highlighted in pink. What's 3x minus 2x? X or 1x or x. I could say either one, correct? So that's x. So x plus 2. I'm good so far. Then let's take care of what's in yellow. What's 4 plus 6? 10. Everybody okay with that? Hello.
Hello. Do you have a student?
Maybe. I do.
Perfect.
Perfect. Is it an escort or just give them the...
He just needs to come later.
Okay. Uh-oh. You can blame me, okay? If they give you any hard time, blame me. You got it? Love it. All right, hey, are we good so far with x plus 2 equals 10? So we switched our equation because we combined our like terms that were on the left side and the right side. Sometimes you might have like terms just on one side. Combine those first before you start doing the problem. After that, we're going to start solving it. So there's only one step to do now. What should I do to get x all by itself? Yeah. Subtract 2 from each side. Those cancel out, so x is equal to 8. Done. Now it says, hey, check your answer. Now, I had a hard time with this as a student, and I kind of have a hard time with it as a teacher. The teacher says, hey, check your work. If I force you to check your work, I'm making you do way more work. Bless you. It's your choice if you feel you want to check it or not. Now, if I gave you a problem on a test or a quiz that said, hey, is this the answer, then please do. Say, hey, if I had this all worked out and I said, hey, this is the answer, check your work, plug it in. So you go 3 times 8, which is 24, minus 2 times 8, which is 16, plus 2. Is that equal to 10? And then I got 24 subtract 16, which is 8. 8 plus 2. Well, this week I think 8 plus 2 is equal to 10. Next week it might be different. But that's how you check it. Now, let's say I give you a smaller test or quiz, meaning it's not going to, you're like, oh, sweet, I should be able to get this done in 20 minutes. And you turn it in and you still have 20 minutes or so left. You might want to just double check, plug it back in to the original, see if the answer works, if it gives you a true statement. If it doesn't work, that means that you might have made a mistake. And you can then go back and change it. But as far as homework goes, it's kind of hard for me to say, hey, yeah, do twice as much work now. Agree? Again, that's come from the teacher. Okay, I'm not trying to insult math or anything like that. The reality is, if I can get it done, fine. If I choose to plug back in and check, also fine. Your choice. My friends, can I move forward to the next slide? All right. Friends, we got the F word up there. We got fraction. Oh, anxiety just set in, right? All right, so let's do this first. I'm going to take some anxiety away here in a second, but let's do what we definitely know how to do first. We definitely know how to do this. Agree? Let's take care of that first. Is that okay? And I get you. I understand your anxiety with fractions, but I know that that's going to give me 13, and then I have this. Okay? Okay, I'm not feeling too good about myself because we have these fractions. But you know what? I learned how to deal with fractions. If I can get away with not doing a fraction, guess what I'm not going to do? A fraction. So can I show you a way to get rid of a fraction? And then that takes the anxiety away? Is that okay? Well, because I can't do math. Is that 7? I don't know where 13 came from. Boy, you got these arbitrary numbers floating through this guy's head. Okay. It's like teachers up there can't even go 12 minus 5. No, I don't know what I was thinking about. I'm sorry. I was trying to think about. Is it correct now still? I'm so sorry.
Yeah, no, that's right.
All right. So, friends, I'm going to highlight in 4 different colors. I have this, I have this, I have this, and I have this. Agree? Yeah. Okay, I like what you're thinking, but can I show you this first? And then if you choose to do it by combining like terms, you're going to still get it correct.
Okay,
But I know right now, because we got the F word up there, we got fractions, anxiety starts setting in a little bit, right? Okay, so my friends, I said I have a way that we can get rid of fractions. This might dial in your thought process a little bit, saying, I get you. Do I have the same denominator on both of my fractions? Agree? 3 is my denominator on both. Agree? Okay, I have 4 different colors up there, so right now I have 4 different parts of this problem. Yes, there's an equal sign, but there's 4 different things that we need to mess with. The equal sign doesn't really mathematically ever get changed. It stays an equal sign if it started as an equal sign. All right, ready? Greatest gift I can give to you. All right, what was the denominator? 3? We just have 3, right?
Maybe it's just 3.
So I'm going to multiply this by a 3, this by a 3, this by a 3, and this by a 3. Okay? I multiplied all 4 of my things by 3. So this gives me 21 right here. That seems okay. What happens here? What do I get? Yeah. Yeah, I just get y. Those cancel. Oh, 1 fraction gone. 1 to go. What's this?
3.
9. What happens here?
Cancel.
Cancel. Hey, friends, I just got rid of the fractions. Guess what I didn't have to add, subtract, multiply, or divide? Fractions. This is a wonderful skill. It's called clearing a denominator. And it's something that we will utilize and keep working with and keep building with and build with as we go along. I can get you through this class without ever having to add, subtract, multiply, or divide a fraction in this kind of sense. Yeah?
But instead of that, could you just subtract 3 and then add them both together?
I sure could have. I sure could have. And I love that you see it that way. And I know some people in here will see it that way. But I know there is over half this class, when you saw fractions up here, it's like, I don't feel so good. Can I go to the nurse?
You do that with any fraction, but
Yeah, you're going to see as we progress and we build through these, we can get further and further and further on these. I'm going to make this kind of a platform that I can write from. All right, so I'm not in anyone's way. That's good. These are like terms, agree?
Yeah.
What does that become?
2.
And notice I'm writing down all the steps. My friends, I bet you some of you might be able to do multiple steps at once. Agreed? Okay. Now let's take care of this. I want y to be by itself. So I'm going to subtract 9 from both sides. Let's see if Stirrup can subtract. 21 subtract 9. 12. Divide by 2, divide by 2. Those cancel. My answer is y equals 12 over 2 is 6. Friends, I just showed you a way to get rid of fractions. I hope you're like, okay, I kind of like what you just did. I'm not sure about it yet, but I think I want to learn this because this is a good thing. Yeah.
If they have different denominators, can you still do
Ooh, yeah. And I bet you we will find something like that. Okay. Actually, we have a little space on here. Let's come up with a problem over here that has 2 different denominators.
change the second y over 3 plus went wild.
Well, let's do this. Kind of similar, right? I have two denominators. One of my denominators is 6. The other one is 5. If I multiply everything by 6 up there, I don't get rid of the 5. Agreed? If I multiply everything by 5, I don't get rid of the 6. Agreed? What number do I get if I multiply 5 and 6 together? 30. So what do you think I should multiply all three of those things by?
30.
30. So if I do this, if I say, you know what, I'm going to multiply this by 30, this by 30, and this by 30, I can start reducing. I can say, you know what, 6 goes into 35 times. That gives me 5x. 30 times 2, yeah, it's 60, but, and again, we just made up this problem, so, you know, it might not be the nicest. Hey, 5 goes into 30 how many times? Friends, I just got rid of the fraction. I didn't have to even do the fractions. I just got rid of it. But I did a math operation to get rid of it. And then if I went and solved the rest of this problem, I can say, you know what, I'm going to subtract 5x from both sides. Oh, this is going to work out nicely. I get this. That answer's totally fine. Some math teachers always want to have the letter first. I take either one of those, happy with either one. Pretty satisfied with it. Okay? Not too bad. I just taught you a skill that can take place from here all the way through the rest of your math in high school. Because, my friends, I know a fraction creates anxiety. And it makes you normal to have that anxiety. I told you my anxiety with when they were trying to teach me fractions. They always referred to fractions as pizza. And I always thought, dude, we're talking pizza. I'm all day long thinking Smitty's Pizza because that's the only pizza place I liked in Arizona. But let me go to the next screen, see if we have something that's a little different. Okay, we got a few of these up here. And I'm rearranging my room as we speak. All right. So let's take a look at this next problem. Do I have like terms? So let's combine those together before we do anything. What do you think? Does that seem good? Add 2, I like it. Oh, let's make 2 sides. Let's add 2. Add 2. Negative b equals negative 9. Now, a couple of you said, okay, that's my answer. Should we have a negative letter or not? No, really what we should do here is go times negative 1 to everything. If I times everything by negative 1, I wind up with that. Is that what you're going to tell me? Thank you. Yeah.
So, if we can just like switch it around, like can we just write our answer as b equals 9? It's like
If you see it, yeah, you don't have this step right here. You don't necessarily have to show. If you realize, hey, that is going to give me that, your thought process is working just fine. And I don't need to see that you multiply everything by negative 1. So basically, some teachers just say, just switch the signs. What really is taking place is we're multiplying everything by negative 1, but it's kind of like a step. I was like, well, I really have to show that? No. It's your choice if you want to. Hey, problem number 2. Do I have like terms on the left side that I need to take care of first? Yeah. And take care of those first. So negative 3y plus 5y is? Agree? Now I can do that's on both sides of my equal sign. What should I do next? Subtract 8. Very good. So those cancel. So I get 2y is equal to 6. Help me out, friends. Divide by 2, divide by 2. And a lot of you don't even have to show that stuff. You can just go right to y equals 3 and say, hey, life is good. Problem 3, like terms. Yeah, I do have like terms on the same side. I'm going to combine those together. That's going to give me 2x minus 7 equals negative 31. Let's make our both sides. Add 7. Oops, let's change colors. Add 7, add 7. Those cancel. 2x equals Something costs $31, so I owe $31. I have 7 in my pocket. How much do I owe? 24. So it's going to be a negative 24 because I owe it, right? Divide by 2, divide by 2. So x equals negative 12. Cool. All right. I feel pretty good about so far what we're doing. You know, like you should do, the teacher. Well, you see me make errors. Okay. So, take a look at that fourth problem. We do have the fraction. Now, it's probably pretty simple to do where we can say we can subtract 4 and multiply by 3. Agreed? But can we apply our newest found rule? What do you think? What do you think I should multiply all 3 terms by? 3. Dude, again, it's your choice on this problem. If you wanted to say, you know what? Let's get rid of that and do this. So I get 3 times 1, which is 3. Those cancel. I get t plus 12. Agree? How should I solve it? Subtract 12. So I find that t equals negative 9. Is that right? And notice I flip-flopped it as well. I guess I could have had negative 9 equals t and then flipped it over. Is it okay to leave it as negative 9 equals t? Absolutely. Just know who your teacher is. This teacher's fine with it. Some teachers might not be. Yeah, I have $3 in my pocket. I want to buy something that costs $12, so I owe $9 still. Number 5 is kind of the same idea. What should I multiply both sides by to get rid of? Multiply by 7. Those cancel. X minus 3 equals 7 times 12, I think, is 84. I think. Add 3, add 3. So x equals 87. So look right here. These 7s cancel each other out. So think about this right here. This technically, because I'm out of that 7, I'm going to group it. So yes, I could go distribute that 7 over the parentheses, but then that didn't get rid of my denominator. It's a great question. What is our entire numerator before we started that problem? X minus 3, that whole thing, right? So if we multiply the fraction that has x minus 3 on top, we multiply that fraction just by 7, just by reducing, the 7s cancel out. And then I'm just left with the x minus 3. Maybe. Let's see if we can fill that a little bit. That one looks a little goofy because you have a whole numerator that is a term. It's an x minus 3. But because these 7s, this 7 here and this 7 here, just by reducing, we can cancel them out. So if I brought this down here, if you did this, right? That's basically what I'm not showing. And then I can say, well, I can say this goes in there once, that goes in there 3 times, and that leaves me the x. Okay. Okay. I know now. I'm learning. I will learn more from you all than I will teach you. Hey, friends. Should we just get rid of the fraction first, or should we add 4? There's not a right or wrong answer. I heard 2 different things, so we'll go with what we heard. Okay. I'm going to add 4 like y'all said. We do have this. And what we had done was we did the reciprocal, but I'm going to rework this a second way as well. So you realize that's over 1. Those cancel. M equals 18 over 2. So m equals 9. Well, let's do this. Let's do this the other way as well. Let's take the exact same problem. Let's clear the fraction. Multiply by 3, by 3, by 3. Agree?
Yeah.
Those cancel. What do you think? Add 12 to both sides?
So it wouldn't be, you wouldn't do the, oh, wait a minute.
Is this and this the same? So there's two different ways to look at it. Some of your brains are going to see the new way. Some of your brains are going to see the old way. What's wrong with the brains that see it one way or the other? Nothing. I'm just trying to give you two different options. Okay? Did I cover everything on that page? Am I done with that page? Do we have any more notes? What do you mean? No. Ooh, at Yummy Yogurt. Where's Yummy Yogurt? I don't know. It's a part of our imagination. At Yummy Yogurt, you pay 35 cents for the container. So you walk into Yummy Yogurt saying, hey, can I get a cup? Yeah, 35 cents. Okay. Then you're going to pay 40 cents for each ounce of yogurt and toppings. So we've all probably been to one of these places where they have like 9 different yogurt machines. And you're like, ooh, I want chocolate and I want strawberry. And you go through and you put a little bit of each. And then you get to the toppings and you're like, best day ever. I'm putting Snickers on it, cookie dough, sprinkles, ooh, chocolate sauce. Right? So, how much are you paying just to get a cup? Okay, you're going to drop 35 cents just to get a cup. That doesn't include any yogurt or any toppings. That cup costs you 35 cents. What is going to influence the price of our yogurt? How much we buy as far as toppings and yogurt. So we'll call it Y for yogurt. So we get up to the cash register. They weigh it for us. They're like, okay, 35 cents plus you got this many ounces of yogurt and toppings. Okay, so now, friends, here's like another kind of a little anxiety in math sometimes. We have decimals. I don't like decimals as much. How many places do I have on each of those decimals? 2. There's 2 decimal places to the right. So let's move the decimal. If I multiply everything by 100, I wind up getting 35 plus 40y equals 475. Now I don't have to worry about a decimal. Agree? This is? Subtract 35, subtract 35? Yeah. Yeah.
So, couldn't you have just subtracted 35?
Point 30, yep. Yep.
4.7.
Yep, yep.
And
Yep.
you would have been able to subtract the 0.40
Mm-hmm.
from that, and
Mhm.
you would have just been able to.
It would have been the same thing.
10.
Yep.
Just 11.
It's going to come to the same exact answer. Yeah, it comes out. I got 11 ounces of yogurt. So I showed it one way where I got rid of the decimals. And sometimes it's nice to get rid of decimals because sometimes you ignore that 3rd or 4th or 5th grade knowledge of you have to line up your decimals. Why? Well, because it's kind of important. So if I get rid of the decimals, so if you choose to do it this way, you're going to get the same exact answer as if you went 0.35 subtract from both sides. So if I did that, if I took my original problem, I took 0.35 away and divided by 0.40 and 0.40, you still get y equals 11. So it's your choice. And again, I'm just trying to give you some alternatives to think about. Question? Stretching. A little bit of both?
Yeah. What if I can head up to my locker real quick to get my laptop?
I'm still teaching.
Fine.
You'll miss it. You'll miss my lesson. I'll send you in a bit. All right. Okay, now 3 consecutive numbers have a sum of 36. Ooh, let's define what consecutive means. Anyone want to think what consecutive might mean? Yeah.
Like 1, then 2, then 3, then 4. Blah,
Oh, so a number right after the next, right? So consecutive numbers would be like 20, 21, 22, or 16, 17, 18, or 3, 4, 5, or 0, 1, 2, or 1, 2, 3. Those are consecutive. They're one after the next. Another word that we need to know. What does sum mean? Yeah. Addition. So this is addition. How many numbers are we going to add up? So I have 1 plus that plus blank, and they sum up to 36. Agree so far? All right, now let's think about this. What is the next consecutive number? This is not where the problem. What's the next consecutive number after 20? 21. What's the next consecutive number after 150? 151. What's the next consecutive number after 0? What's the next consecutive number after 7? 8. What number am I adding to a number to get to the next consecutive number? 1. So my first number is going to be x. To get to my next number that I don't know, I'm going to add x plus 1. Right? And then I'm going to go x plus 1 plus 1. So let's clean this up a little bit. Basically, I did this. Agree?
No. X plus 1.
Oh, there should be an x plus 1. Love it that I have smart people with me. All right, do we agree with this? So the x came down, the x plus 1 came down, and all I did here is I made that x plus 2, right? Hey, x, and x. If I add x, and x together, how much do I get? 3x. If I add 1 and 2 together, I get? It's equal to 36. Subtract 3. So I get 3x is equal to 33. So x equals what? Okay. What are the numbers? Well, if this one's 11, what's the next number after that? What's the next number after that? Are 11, 12, 13 consecutive numbers? Yep. If I add 11 and 12 and 13 together, do I get 36? I hope so. Yeah, because if I go 11 plus 12, that's 23. 23 plus 13, 36. Now we changed it a little bit. I think we're okay on consecutive. But what happens with, what's an even number? 2, 4, 6, 8. So what do you have to add to a even number to get to the next even number? 2. Yeah. Question? Yep. So there's my 11. Then my next one's 12. Then my next one's 13. Right? That makes sense? Yep. 12 plus 12 plus 12, I totally agree, is indeed 36. But I'm looking for consecutive numbers, and 12 and 12 and 12 are not consecutive. They're the same. So I'm looking at for one after the next after the next. But this one talks about even. So in order to get to the next even number, you have to add 2. So I have 2 consecutive numbers. So I have this, and sum, again, is plus, and they equal 166. So if this number was x, and that's an even number, what do I have to have for the next even number? X plus 2. I have some like terms. X plus x is 2x plus 2 equals 166. And then we're just doing a little math there. Subtract 2, subtract 2. I tried to change color, but it didn't change on me. 164. Divide by 2. 2 goes into 16 how many times? 8. 2 goes in 80 what? 82. Is 82 an even number? Yeah. So if this is 82, what's the next number have to be that's even and it's consecutive? That's it. If I add 82 and 84 together, I get 166. Was that all the notes? That was? Yeehaw! All right, so my friends, I'd like you to have a good, solid try. Let's see. It's
1920?
page 1920, and let's do this. What do we say we do the, why don't we try the odds? Yeah, just do the odds. Now, here's the nice thing, my friends. Here's the nice thing. If you just do the odds and you get stuck, if you go onto my Schoology page, I have the odd answers on video. So you can click and watch the video, and it gives you like a 3 or 4 minute thing to go through all the problems. And it's me talking. Do what? We might warm up on those. No, it wouldn't be homework. No. All right, friends, we out of here 11. Get out of here. Don't forget your phone. Got mine too.
Mr. Star,
Yes.
during 6th grade, could I come over and we could do like the homework for tonight on